Welcome to another unit in business mathematics. This time I'm going to talk about the substitution rule for integration. While the substitution rule is related to what we know from derivatives as the chain rule, it's still deduced in a slightly different fashion and does not directly result from the chain rule. So if we want to motivate this, we're basically starting on the left with the integral of a function f of x. So we have f of x dx. And what we're doing then is basically what I put here into the headline. We're substituting x with a function g of t. If we put the g of t here for this x, we also have to put it here with the dx. So we get basically this expression here. I'm not going so much into detail why we have to change lower and upper bound as well, but this is something to recall as well. I just want to focus on what actually happens here. So in this case, we inserted g of t for x. The problem is we have this dg of t. To make this a bit better understandable, we basically apply the d, which is just a derivation operator, meaning we can make this a bit easier by simply getting the first derivative of g. And this is what happens when we pull this in front of the d. So if we basically pull the g out of this d operator, we get the first derivative of g, and the d operator is left only with the variable t. So in other words, we can remember when we actually substitute dx with any specific function, we basically have to multiply all of this with the derivative of this function. This comes from the fact that we use this here in the dx as well, and the d works like showing us have to do a derivative here. Well, if we do the derivative, looks like this, then we already have our substitution rule. The only difference with the substitution rule and the way I tried to derive it here is that the substitution rule works the other way around. I tried to come up with an idea which part of my original function I can substitute, replace with an x, and where the corresponding first derivative is. So take a look. Can I actually replace part of my function with an x? And the only thing that is left then is only the derivative of this function I'm going to use. If I can find such a function, I can simply replace all of this with the function f. So with the simplified version after the replacement. That's actually a problem because in some cases it's pretty hard to actually find out what is this function g. So what you could do instead is you decide, okay, this is the function g of t. Then you basically replace this part g of t with an x, and you simply divide everything else by the first derivative of this function g. If you divide by this, if it's actually given here, this will turn out to be 1. Well, it doesn't necessarily have to be 1. Could also be like 3, 4, 5. In this case, wouldn't actually impact your solution a lot. The only important thing, after substitution, the only variable you're allowed to have is the x. You're not allowed to have any t anymore after substitution. So if you're not sure, just try this out. Take one part of your function where you substitute g of t for x, simplify it, and then divide the rest by your self-determined function g, or its derivative thereof. If this actually cancels out insofar that only constants or numbers are left, you're good to go and can actually simplify it in this way. Well, that's everything to say about the substitution rule. So I say goodbye and see you next time.